This week we'll be discussing some principles of hard surface modeling. We'll cover some terminology on edge profiles. We'll talk about topology and edgeflow. We'll cover some subdivision modeling techniques. We'll talk about mesh resolution, when to go high and when to stay low. And we'll also jump into Maya, set up our preferences, learn how to create some shelf buttons and hotkeys, and we'll also cover the tools we'll be using most throughout the course of this class. So the question is, what is hard surface modeling? And it's hard to get a clear definition. I've heard some distinguish it from organic modeling by saying hard surface models are models of man-made objects. But what about something like this man-made couch that's soft and pillowy with wrinkles and skin texture? I've also heard that hard surface models are models that don't deform in the way the character model would. But sometimes a hard surface model does need to deform, like this crumpled soda can. I've heard that hard surface models are models that have angular or hard edges on them, but this rock face is something with hard edges that is very organic. To me, hard surface modeling isn't about the subject matter. Instead, it's about the precise control of topology. It's about communicating function and scale, and it's about speed and efficiency. Most importantly of all, it's about making awesome robots, cars, and/or spaceships. So, let's talk about some principles of hard surface modeling. The first thing I want to talk about are edges. When you create a cube in Maya, you get this mathematically perfect arrangement of vertices in space that's connected by infinitely sharp edges surrounding perfectly flat faces. Now, this type of object would be completely impossible in the real world. But before I get into that, I want to discuss some edge profile terminology. So imagine you work in a wood shop and you've been asked to change the profile of this edge on this block of wood. The first thing you could do is bevel the edge, which would essentially be removing that entire corner that edge lives on. You would start at this bottom corner and cut up at 45 degrees. The second thing you could do is chamfer the edge, which is basically a less severe version of the bevel. You would start about halfway up the block and cut upward at 45 degrees from there. The third option would be to fillet the edge, which is essentially rounding it out. But there's something that these three options have in common. In the real world, every edge has a fillet on it. Take the keyboard in front of you. It's made of all these small manufactured parts with hard edges on them, but when you zoom in, even the most precisely machined edge has some curvature to it. Even a razor's edge has some curvature to it. So if we go back to Maya and we zoom in on this beveled edge or this chamfered edge or even the initial block we started with, we can see that every edge on here is filleted. So why am I bringing up these edge profiles? If we look at our cube again and we want to change its perfect CG edges to something more realistic, we're going to want to add fillets to all these edges. But in order to do this, in Maya we would use the bevel tool. And when you click on the bevel tool, you can see what it initially does is chamfer the edges on the cube. And as we add segments in this floating channel box, we create a fillet. So it's this weird, confusing turducken of terminology, but I wanted to clarify it for this class. So even though we may use Maya's bevel tool, which is actually a chamfer tool, to create our fillets, we're still going to be calling them fillets. In this class we'll be making our edge fillets using subdivision modeling, meaning that at render time the mesh gets subdivided or smoothed. When we look at these two meshes in shaded view, they look the same, but when we look at the topology, we can see the one on the right has two edges on either side of the plane change. When we hit the 3 key on the keyboard, which is Maya's smooth preview, we can see how differently these meshes interpolate when they're smoothed. The mesh on the left has a fillet with a radius that runs pretty much the full length of the two faces, while the fillet on the right is stuck between those two edges. We call these supporting edges. Here are another two meshes that look identical in shaded view, but when we look at the topology, we can see that the mesh on the left has supporting edges that follow the curve of the plane change, while on the right, you can see the supporting edges flare out. When we hit the 3 key to smooth preview these two pieces, the fillet on the left is pretty much constant, while on the right it goes from a tighter radius to a softer radius. One of the challenges of hard surface modeling is controlling the edge flow over complicated plane changes. If we look at this mesh, we can see two ramp shapes that flow out of the main surface. Either side of this ramp is supported by edges, but we are also controlling the fillets of the ramp by supporting the edges on the sides of the ramps. Here's an even more complicated shape where a pill shape is protruding from this top surface here and also carving out this lower surface. The challenge here is actually supporting these edges where these shapes intersect while simultaneously maintaining the curvature of the main surface, so when you smooth it, nothing really looks out of place. To complicate this even further, I have this same shape, except I've carved a part line out of it. You can see how the part line is supported along this edge and also how it's supported on these corners. You will notice that there are triangles in this mesh, but since it doesn't have to deform like a character mesh would, triangles are perfectly acceptable. The main thing that's important here is maintaining this edge through here that actually informs the curvature of the main shape. And when you smooth it, all the surfaces look like they belong together. So, let's look at some more practical examples of this. This is a 1956 Bel Air model that I made when I was a hard surface modeling student, but it demonstrates a few things I want to discuss in regards to edge flow. If you look at these edges on the front of the fender, you can see that some flow down the form of the fender, while others flow back toward the wheel well and meet up with edges that go around the wheel well. It's like a bunch of rivers that flow over the mesh, and when two rivers flow side by side, you get these 5 corner junctions. Controlling the way these edges flow together is one of the more challenging aspects of hard surface modeling. If we look at a shape like this piece of trim, there are edges that flow down the front and define that leading edge, and then there are individual flows that create these scallop shapes. Even on something like the rims, there are flows that travel around the main shape of the rim, but you can see the way these flows meet the flows that go around these holes. To give a more extreme, planar example, this is a model of the Batman animated series Batmobile that I modeled a few years ago. These edges along the front and how they brush up against the loops around the headlights and wheel wells illustrate what I'm talking about. This corner of the hood is a perfect example of edges flowing together to form a hard corner. It's almost as if the two flows intersect instead of butting up against each other. Back here by the quarter panel is an example of maintaining curvature while cutting into a surface. And you can see that there are a lot of triangles that are there as a result of the nature of the cut I made. Along the back fins there are edges that flow from the corner of the wheel well and terminate on the points of the signature bat scallops. These are just some examples of edge flow for hard surface modeling though. It's one thing to show a completed model, but we will get into these ideas way more extensively in future lessons when we're actually modeling. This is an image of a 2013 Chevy Cruze door panel. This is actually the car I drive. This isn't an image of my actual car, but this is the car I drive. So this is something that I'm familiar with. It's something that I see every day. And I wanted to illustrate the point that as you get more into hard surface modeling, this is how you'll start to see the world. So I've mapped out all the hard edges of this door panel, all the edge flows that spiral around and butt up against each other. You can see this 5-corner junction here where they meet. One of the areas I thought was actually cool was this point here. You see where the 3 edges come to a point, and then you can actually see where these fillets would be generated in this image, kind of just based on the lighting here. And you can see these other areas where I've terminated edges. Sometimes if you carry these edge loops all the way through your model, you'll get these weird kinks in your curves. So I find that if an edge isn't going to extend past a certain point, it's best to just terminate it. You can see this edge kind of ends on this other edge. So I kind of just collapse all the edge loops together into on a flat plane at that point. This is kind of a good exercise. I'm not going to require this for this class, but I definitely would encourage you to draw stuff out on paper if you're struggling with how the edge flow should be. It's way easier to just draw something out quickly than try and figure it out on your model if you're struggling. The other cool thing about drawing over images, though, is you do get to see the size of fillets, and it kind of helps you get a sense of the scale of what you're modeling, or how tight the radius on these fillets should be. Let's talk for a bit about mesh resolution. So after I graduated from school, I had a handful of car and spaceship models that I wanted to showcase in an environment. So I decided to model this airplane hangar. Here's what it looks like on my student reel. Now this shot is nothing fancy, it's just a simple dolly forward. But that's because this took forever to render, particularly this area here. Now granted, this was 6 years ago, and computers have only gotten faster and better, but at the time this taught me some valuable lessons about level of detail and mesh resolution. Here's a couple more in-progress renders of this thing. You can see the final gather artifacting up here. We'll get into that when we're rendering. But let's take a look at it in Maya. So the first thing I did was started building myself this industrial building toolkit. And you can see it includes a few doors, some options for lighting, and a few props. Now when I first built this stuff, I thought to myself, I'm going to trick this stuff out and I'll never have to model any of it again, especially these pipes. I figured these things would have a lot of reusability. But as I worked with them in context, the scene started to get really heavy and renders started taking a really long time, so I had to kind of revisit them and lighten them up a bit. If I zoom in and look at some topology here, you can see that there's not much here, and a lot of these parts aren't even built to smooth. But looking back at the shot, you can see they're so small in frame that there's really no reason to smooth them. You can also see how low poly the walls are. I left them pretty much polygonal. The point I'm trying to make here is that it isn't always appropriate to model everything to smooth. The fillets on those walls would have been so tiny they would have never shown up in renders. These bolts on the pipes, for example, have a chamfered edge on them, which is probably too much considering how far away the shot camera is. This is usually true of things like bolts and screws on models. The basic rule of thumb would be, if a fillet on your model is less than a pixel wide in your renders, they're not going to show up and they may as well not be there. Now, it's a little difficult to quantify this when you're actually modeling, but nowadays I'm much more inclined to keep the model as light as I can and add resolution later if I happen to need it. I'll get more into this philosophy later in the class. Alright, let's jump into Maya and adjust some preferences. So preferences can be found under Windows, Settings, Preferences, Preferences. And the first thing I'm going to want to set up here is Autosave. Autosave lives under File, Projects, and just enable it here. 10 minutes is a little too frequent for me, so I usually set that to a half hour. And I like to limit the amount of autosaves that I save to 5, just to save disk space. Typically when I'm working and I reach milestones, I like to version up. So if I need to go back, I usually will depend on those files rather than autosave. Autosave is really more of a safety net in case Maya crashes, which sometimes happens. The next thing I want to turn on is under polygons, and it is border edges. And I'll set that to 4 so we can see it better. If you create a sphere, for example, if I create a sphere and I delete this face, you can see a nice thick border edge. This will become important later because if I were to do this and actually detach, you can see that these verts are on top of each other, but they're separate verts. If I were to go and actually toggle this border edges off, you can see that these verts actually look like they're together now. They're merged together, but they're actually separate. So we want to keep these on just so we can kind of safeguard and check that our meshes don't have any unwanted holes in them. So the next thing I want to shut off in here is actually the color management. And you can see on here it toggle it on and off. It's kind of just this extra thing that your graphics card is doing, and not really important for modeling, so I like to come over here and just shut it off. And that's all the preferences we need to mess with right now, so just exit that, save and exit. So there's different ways of working in Maya. Some people like the marking menus. If you hold down space, you can kind of see there's all these different menus that come up. The only marking menu I typically use is the control right click marking menu, which has a bunch of selection tools that I'll go more in depth on when we're actually modeling. But typically if I'm going to use a tool, I like to keep it up on the shelf. So I will show you how to make some shelf buttons now. The first shelf button I like to make is delete all by type history. And construction history is something that happens when you, it's something Maya keeps track of when you do edit a mesh. Like for example, you can see our deleted component here is actually the face we deleted, and the split edge is actually the detached edge that I made. So it's, as you work, you don't really want to carry this stuff around. It can get kind of bog the scene down if you have a lot of it in your scene. So I like to hit this delete history button pretty often now that history's gone. The good thing about history though is you can actually go back and edit things, but I'll go further into that when we're actually modeling. The next button I like to use is in here, and it's the delete edge vertex button. So I'll go ahead and control shift click that, give us the button. Basically what that does is if you go in here and say you just hit delete on this edge, you can see there's still like a kink, and it's actually because the vertices are still here. So what this button does is takes that edge selection and it actually deletes the vertices as well. It's kind of just a cleaner way to delete edge loops. The next tool that I like to use is the merge tool. And I'll go ahead and control click that, but I want to click on the options here to show if you reset the tool, it defaults to 0.01, and what that will do is if I move this very little and we hit the merge button, you can see that it merged those 2 points together, but that isn't always what I want. I kind of only want the points, the only points I want to merge are the ones that are exactly on top of each other. So if I set this back to 001 and hit apply, only the verts that were right on top of each other have been merged. So I like to just hit that and hit apply again, and you can see that it is only merging the verts that are right on top of each other. The next button that I like to add is actually merge to center. So control shift click that, and you can see what this does. It'll take this edge selection here and basically merge it to a single vertex in the center of the selection. So it's kind of a handy one to do. I use this as kind of a brute force merge tool. The next tool that I like to use is actually under mesh tools, and it's the slide edge tool. So what this tool does is you grab an edge and you can kind of slide it around, and you can see that there's snapping here. If you actually go to the tool settings for this tool, you can actually turn that off, and now you get kind of like a more loosey-goosey kind of slide. But I typically just leave the snapping on. Let me delete this. And this is actually an example of where you will use your history. is you can see the polyplane here, and it actually is set to 10 spans by default. I'd like to set that to 1 just to kind of illustrate this. But Maya has this multi-cut tool, and this is kind of a new tool, and you can actually do a lot of cool stuff. You can draw basically topology on a mesh, and now it's built that as an edge. But one of the features that it has is you can kind of draw across a mesh and cut all the way through. But for that, I really like to use the old Maya cut tool, which is really like, unless you know the command, you can't really get to it. So it's actually cut polygon, and if I hit enter, you can see the tool has loaded up here. And what it does is you actually click on a point in the center of the mesh, and you can drag this around, and you can shift to snap it to different angles. And yeah, I just find this a little more handy, especially when you'll see more when I'm modeling, but yeah, I just find this tool a little better. But it's hard to get to unless you know the command, so I like to put it on the shelf. So what you do is middle mouse drag and put it right up there, and now it's on our shelf. There are a couple of scripts that I would like to add to our shelf. In particular, these 4: comment rename, LF auto crease, set texel density, and switch cam are the 4 scripts we're going to be working with. So make sure those are in your Documents Maya 2017 scripts folder. And once they are actually in there, you can just type rehash in here, and that'll kind of reload your scripts. So the one I want to load first is actually comment rename. And if you hit enter on that, you can see this little window pops up. And this is actually a naming tool for naming meshes that we'll be using in further, like, later lessons. But to get that on the shelf, you actually type it in, select the text, and middle mouse drag up to the top. Save it as Mel. And then we can go in and edit and put the label as CRN for comment rename. So the other one is LF auto crease. We'll go ahead and make that a Mel shelf edit. So I want to explain what this auto crease script does really quickly. So I'm going to create this cylinder, grab these faces, extrude them out, and scale them down. So what we have is kind of this shape that wants to have softened normals around this curve, but hardened normals around here. And it's already automatically like that, but sometimes you'll be in a situation where it doesn't look right, and it's all the normals are soft or something. So if I grab this piece and click this auto crease script, you can now see that it's kind of selected exactly the edges we want that should be hard. And what this is doing under the hood is, if I soften these again, is it is setting the normal angle by 30, which if you apply and close that, you can see it's all these edges are selected now. But the extra step that this auto crease script has done is done a select, use constraints, and if you set this to edge mode actually and do hard, that's kind of the selection that the auto crease script has given us. So this kind of comes in handy if you want to say I wanted to fillet these edges. I could make this selection, and let me just kind of start over. Mesh display soften edge. Could make this selection with auto crease. Make sure I'm in edge mode, and then go to bevel. And now I've kind of got a... So now let me add some segments. So now I've got fillets on these edges. It's just a kind of a way of selecting edges in a predictable way. And finally, set texel density. So without going on too much of a tangent, I want to talk about what this set texel density script actually does. If you click on it and open it, you can see that there's this little window with two fields in it, texel density and texture resolution. And texture resolution is your map size, but texel density is a little more of an abstract concept. It's kind of the amount of texture space your mesh takes up. To illustrate, I'm going to create a cylinder, and we'll go ahead and create a new material. I'll grab this and put a file. This should automatically open your source images, and I have a UV checker in here already. So now if we go here and hit 6, you can see what this is doing. You can kind of see how the texture is on here. The side's a little bit stretched, which has to do with how the cylinder is when you bring it in. So I'm going to just go ahead and fix that problem. And grab all these UVs. And then, actually, if you go to the options on this, you're going to want to make sure that it's Unfold 3D and not Legacy. Go ahead and hit Apply and Close. And now you can see this is much more even. The squares on top and the squares on the side are kind of the same size, which is exactly what you want when unfolding UVs. So this is fine and good. If I go here and scale this to uniform, set this to free, and kind of lay this out, we have kind of our this is kind of a good UV layout for this piece. But say I duplicated this piece and sort of moved it out here and made this smaller. This is what different texel density is. The pixels on this mesh appear larger than they do on this mesh. So what we want to do is kind of figure out what this texel density, what the ideal texel density we're going to want is. So this is actually an older plugin. The person who wrote this is also responsible for plugins called Nightshade, which actually rearrange your whole UV window. Some people like Nightshade. I kind of thought it was a little too invasive, but I do like the feature of this set texel density. So I kind of went back in time and his website and dug this up. So say I set my map size to 1024 and I want to figure out what texel density I want on this piece. So if I go ahead and hit apply, you can see this made this quite a bit smaller. Let's try 200. That's a little too big, so I'll go back and let's try 150. Closer. 160. So that's probably as close as, like, I could probably dial this down and get a little closer, but I'm actually kind of happy with that because I know that this is going to need a little bit more space too. So we have a texel density on this mesh that we're kind of happy with. You know, you have to get this close to kind of start to see pixels, but I want this value to be on here as well. So what I do is you just grab this and hit apply, and you can see that it shrunk these textures down, but now they actually have the same texel density on them. So now what I can do is kind of grab this shell and grab this shell, and it's a little bit out of bounds, but I have a texel density on these two meshes that is the same and that I'm happy with. So it's I'll get more into this in a later lesson, but that's kind of basically what this script does. So the last script that I mentioned is actually switch cam, and if we create a torus here, so there's multiple ways of viewing this. If you actually hit spacebar, you can see that there's the top view and the front view, and you can kind of spacebar in between these four windows. But what I like to do is use this switch cam script. So what the switch cam script does is, if you're kind of near the top view and you enter the switch cam space 1, it kind of creates an orthographic camera. And if I type that again and hit enter again, it goes back to perspective, but now it's switch cam perspective. So what I want to do is make this into a hotkey. So what I do is go to Settings, Preferences, Hotkey Editor, Runtime Command Editor, and then I can enter switch. If I say new, I can do switch cam 1, and let's just name this switch cam hotkey, and I'll just save this. It already exists, so because I've done this before. But if I type it in here, switch cam, okay, so I just have one. So I want to make this Alt C, and you can see that this is assigned to toggle color feedback, and I don't never use that, so I'm just going to hit yes. So that's saved. The thing to notice though is Maya default has been now replaced with Maya default duplicate, and that's going to be important because when you exit Maya, it's going to load Maya default by default. So what we need to do, save and close. So Maya has added these workspaces up here, and it's kind of like a different workspace for every discipline, but I like to just keep it on Maya Classic. That's kind of like what I'm used to, what I need. So in order to get the hotkeys to load though, you're going to have to actually link a hotkey set to the workspace, and this is by default, it's unchecked. So you're going to want to link a hotkey set to this and make sure that it's Maya default duplicate, which is the one we just made, and apply and close, and then you can see when I hit Alt C, now my switch cam will create the orthographic views. So that's kind of just a handy quick way of switching views. So that is hotkey setup. One of the things I like to change right off the bat when I open a new Maya is change the background. I actually prefer this gradient, and the hotkey for doing that is Alt B. This kind of just helps me organize things. So if I call this like sheet and call this donut, it's kind of it's just helpful way to keep me cognizant, I guess, of the naming and organization of my scene. So I like to have that open when I work. The last thing we really need to do before we get into modeling is set up a project. So I'll open up this project window. New project. I want to make one called CGMA. And you can see create all these directories that where you save your Maya scenes and save some source images that we'll definitely be using. And then here's where your autosaves are as well. So if you hit accept there, and then we go over here, documents, Maya projects, and now you can see CGMA, and here's all the directories that we're going to need. Now that we've set up our preferences and hotkeys in Maya, I'd like to go over some of the tools that we'll be using most often. The first thing to cover is the shelf. Now, we already added these buttons to the shelf in our last video, but there are a lot of other tools up here that we'll be using. The first is creating primitives. So if we create a sphere, maybe move this over here, create a cube, move it over as well, and a cylinder. These are the three primitives that I use most often. And when you create primitives, they come with construction history that we can modify to suit our modeling needs. So if we open this up, you can see there's different fields here that we can change. The radius is by default set to 1. If we set this to 0.5, you could see that that shrinks it down to have a radius that's basically half of a centimeter. The one I adjust most often on this cylinder is the subdivision axis, which you could enter a value, like say you want a 12-sided cylinder, or you could also select this channel and middle mouse drag and take the amount of edges down to whatever you want. So let's say I wanted to make this into a bolt, so I'd have 6 sides. You can do the same sort of thing with the cube. If you select 3 channels at once and middle mouse drag, you can slide that way. You could also just do them one at a time. For the sphere over here, on a sphere I like to have faces that are a little more uniform, meaning that they're not so much rectangles, they're more square. So I'll take this down to something like 12 and this down to 8. And you can see the faces are more square, and it's a little more, the topology's distributed a little more evenly. Now that we have some geometry to work with, I want to talk a bit about manipulation. The Q key is kind of your basic selection tool, but if you hit the W on the keyboard, you get the move tool. And you can move this around based on the camera. You can move it down one axis at a time, or you can move it along 2 axes at a time. And this is kind of a newer feature, but it's one that I actually really like. One of the things you can do is grid snap. So what I did there was hold down X and snapped to various points on the grid. If you hold down the V key, you can snap to points. So you can see we're snapping to points on the cylinder now. Holding down the C key is curve snap, but you can actually use curve snap to slide along edges. So you can see we're sliding along that edge of the cylinder. So let me grid snap this back over here. If you hit the E key, you'll get the rotation tool. With this tool, you can kind of freely rotate, or also you can rotate along axes. You'll notice if I go back to the move tool, it's oriented to world space. But if I wanted to slide this cylinder along its axis, if I hold down the W key, you can see I can change from world mode to object mode, and now I can move this object along the axis that it's been rotated to. If you hit the R key, you get the scale tool. And you'll notice that the scale tool, like the rotation tool, it automatically matches the orientation of your object. So you can scale in all 3 axes, scale along 2 axes, which is kind of a neat effect. It'll retain the thickness along this axis, or obviously scale along a single axis. So that's pretty much the basics of manipulation. We'll get into more of the functionality of these tools as we need it throughout the class. So now I want to talk about component selection. So if you right click over this object, you'll see there's all these different components that come up in this marking menu. If I select vertex, you can see that the vertices become live, these little purple dots, and you can move things around like this. If you control right click, you see there's a few options here. The only ones that really work for vertices are growing the selection, which you can see just grows the selection, and shrinking the selection. If we go right click again and go to edge mode, you can see that we can select edges one at a time. If you double click on an edge, it will select the edge loop. If you click an edge and then shift double click the edge next to it, you'll select the edge ring. There's also some other tools you can use with edges. If you control right click, and there are these down here, edge ring utilities and edge loop utilities. So if we simply go to edge loop, you can see that it's selected the edge loop. If I go down to edge ring, you can see it selects the edge ring. And there's a couple of tools in here that you could use. If I select this edge again and go to edge loop and delete, you can see that it does the delete vertex on that edge. If you go to edge loop and duplicate, it'll create edge loops on either side of the edge you have selected. If we go to the edge ring utilities and do edge ring and split, it'll create the edge loop intersecting with the edge that you've selected. This is a tool I use pretty often to add edge loops to geometry. If you go over here to the channel box, you see we have some options that we can play with. If you change from relative to multi, we can now add divisions to the split that we've just made. And this can come in handy later if you're creating something that's like a grill or a grid and you need perfectly spaced edge loops along an edge. If we go to face mode, if you double click a face, it will select the entire object. If you select a face and shift double click the face next to it, it'll select the ring of faces. You can also use the grow and shrink selections with faces. Another thing you can do with face or edge mode is convert the selection to vertices. You can convert to UVs, which we might do later. Or you could select edges. So that will select all the edges. But one of the cool things that you could do is select the edge perimeter, which selects the edges that surrounded the faces you had selected. One of the tools we'll use most often as modelers is the extrude tool. And you can see what it does. It pulls the faces away in a certain direction. You can also use these other arrows in different directions. You can even scale the selection down. Pull it up. This is something you can kind of play around with and figure out. If you hit the G key, it will repeat the last action. So as you can see, it's another poly extrude. If we alter the offset here to maybe 0.1, you can see that it's created an offset between this edge and this edge of a specific amount. So if we go back here and change this to maybe 0.05, you can see that it's a quick way to add an edge loop around the faces you're selected. One of the other options of an extrude is, say I did this and I turned keep faces together to off. It's made actually two separate extrudes out of the two faces that I've selected. We'll get into more things you can do with extrudes later, but this is kind of, the extrude tool is really one of the cornerstones of the modeling process. So one of the other tools that we use quite often is this multi-cut tool. And if you just grab the multi-cut tool, you'll see it will kind of snap to this vertice here. If I just click on the surface, you can see that it's enabling me to draw on faces, but I can also slide here and draw along edges. And if I do that and hold the shift key, you can see that these little dots with percentages show up. And this is kind of a cool way to, like, say if I wanted to make a ring at 40%, it's a cool way to be more precise when you're drawing in topology. If you right click, that will actually complete the tool. Some of the other things you can do, if you hold down the control key, you can see you can drop in edge loops. If you hold down the control key and the shift key, you'll notice that there's snapping. And this is the same sort of percentage snap setup as when we were drawing the topology earlier. So one of the other cool things this tool does is you can actually drag along this edge and hold control and shift, and it will do right angles. So if we go, you can see that this has created this right angle here. If we go this way, it creates here, or this way here, or a right angle from the point of origin. That's if you hold the control and shift key when drawing edges. Your assignment for this week is to select 3 potential concepts of something you would like to model over the course of this class. This is the concept that I will be modeling. It's something I designed specifically for this course because it covers a lot of bases in terms of what's expected from a hard surface modeler working in the industry. I would like you to select your concepts based upon 3 criteria. First, your concept must contain complex surfaces involving intersections of forms, compound curvature, and some sort of part line detail. Second, your concept must contain a fair amount of nondescript greeble detail. A greeble is a detail added to the surface of a larger object that makes it appear more complex and therefore more visually interesting. In this area, the more loose the concept is, the better. Part of the job is to design details that sell scale and function of your model. Finally, the concept must contain some kind of mechanical element. This could be suspension, mechanical limbs, landing gear, etc. In a future lesson, we will explore some light rigging and animation techniques to bring these mechanisms to life. Beyond these requirements, I'm pretty flexible. I want you to select concepts that you would be happy modeling because I will choose one of the 3 that I feel is most appropriate for this class. I would recommend that you do not choose something that already exists, and I would also recommend that you look for concepts that get the idea across, but stay loose and painterly. Here are some resources I recommend for finding great concept art. ArtStation has become a great community of artists and has been a worthy successor to CG Hub, which shut down a few years ago. You can see a few examples of what we're looking for on the main page here, but they were awesome enough to add filters to help narrow our search. Here's a look at their transport and vehicles filter. Another site I like to check from time to time is conceptships.blogspot.com. If spaceships aren't your thing, they have a network of other blogs that cover various other conceptual subject matter as well, such as concept vehicles, concept tanks, and concept robots. Links can be found at the top of this page. Let's look at a few examples of acceptable concepts for this assignment. So this would be a good example of a concept that would be good for this class. I kind of just went through a few of these sites and found the first 8 concepts that I thought were cool. This one's got some great complex curvature to it. It's got some great part lines. You have some nice greeble detail here. Obviously it's a mech, so it's mechanical. So it pretty much meets all the requirements. This is a great example of some complex curvature and part lines. I would suggest finding something with a bit more greeble detail, but there are definitely areas in here that are nondescript that we could trick out. And landing gear is definitely an acceptable mechanism for the exercises we'll be doing later. This is a great example of a concept, but this image in particular might be a little more difficult to model because there's not much information about the depth here. But this has great complex surfaces with some part lines. It's got some mechanical detail, also some opportunities for doing some cool greebles. So obviously this has some nice complex surfaces, part line detail. It's got mechanism, obviously, since it's a vehicle here, and it's got some opportunities in here and on the back for some nice greebles. Same deal here, complex surfaces, part lines, greeble detail, mechanism. Awesome complex surfaces, areas for greebles, mechanisms. And this is actually a really cool vintage one, but it's got some great surfaces here, awesome part lines, and opportunities for greebles. The only thing this would need would be a mechanism, but we could design some landing gear for it. I'm open to that. So I think you get the idea. It's about finding vehicles that are awesome shape, with opportunities for detail and mechanical elements to them. So with all that being said, I wish you luck, and I'm looking forward to see which concepts you choose.